Hey everybody, welcome back to the second episode of the audio webinar series. My name is Ricki Cook. I am head of audio here at Hillsong in Australia. With me, got my friends, and we're gonna talk about digital audio transport today and how we use that at conference. So I'm just going to run around and quickly introduce everyone. As always, my favorite sidekick, Madeline, is running moderator. She'll be in the chat. Feel free to reach out to her and drop any comments. And Juzzy, give us a wave, Juzzy.
Hello.
So Justin is a freelance audio engineer, systems engineer, systems designer, basically like a systems architect. So we use Juzzy's services a lot here. He's a good friend of mine. We've been friends for many years, and kind of grew up in the industry together. So yeah, so no, we use a lot of Juzzy services for designing PAs and tuning them and all that good stuff. And as you'll see today, when we start getting stuck into some drawings, you'll see the sort of stuff he comes up with for us. And as always, Andrew Crawford, aka the Mix Wizard. Andrew's been, I don't even want to like, okay, if I were to put a number on how many years of actual experience, what would you say, Groff?
Well, I've done 30 Hillsong conferences. So
okay, yeah, so that's just to put it in perspective. Yeah, yeah. Okay,
I'm
so
the old guy. You just say he's the old guy that won't go away. He hasn't figured it out yet.
that is definitely not the case. All right, so Croft is basically our numero uno front of house engineer for Hillsong in Australia. He primarily mixes a lot of, still mixes, he's still on team here. So Croft spent many years working as a record engineer, project manager and producer for a lot of Hillsong albums. And then also focused on mixing front of house for a lot of our large events, and still is on team, still volunteers on weekends to mix services. So yep, super thankful to have him. Yeah, so like I mentioned before, we're going to talk about digital audio transport and how we use that in, well, the methods we use in Hillsong Conference, especially because like I mentioned, if you watched the first episode, we don't have, like, we've postponed Hillsong Conference for this year. So 2020 is moving to 2021. And so around this time of the year would traditionally be, this is where we'll be having these conversations, and this is where we'd be doing these drawings, and this is where we'll be designing and sort of architecting that system. And a lot of the time, a lot of it's copy and paste from the previous years. We've sort of come up with formulas that we've found that work, and we sort of stick with them. And we, you know, and we keep deploying those, because once we've sort of gotten into a groove, or we stick with what we know, or, there's many reasons why we keep rolling out the same thing. However, each year, something always changes. We can't help ourselves. We just have to, well, I can't help myself. I just have to change something here and there, or sort of tweak something or fix something up. So yeah, it's a lot of fun. So what I'm going to do is basically, I think we're going to start with kind of discussing our history and the evolution of where we've been through time with consoles, because the console network is sort of the fundamental, the underlying, the baseline of where we, what we base the network from. So if we will look at it like a hub, the console network is our hub, and everything comes in and out, of the console network. So especially in the arenas anyway. So over the time, you can see in Juzzy's background there, he's got a Digicode D5 Live, classic. I love that board. That was actually Hillsong Conference in 2005, if I remember right, at the Entertainment Center. No, 2011, sorry, at the Entertainment Center. And then post that, we went on a journey with Midas Pro Series and XL8s, which if you're not familiar with those consoles, they primarily use AES-50 as their transport protocol. So the mechanism is fundamentally, it's 24 channels at 96K on a shielded Cat6 cable, and you just keep adding them the more and more you want. Like an XL8, I think it's got like 10 or so. It's got a lot of AES-50 IO ports on the back. you would start using those as your hubs and you build out from there. We would often we'd build the network in the shop and we'd have it running for a week, and then we'd get out on site, and that's when we discover there's, new problems with clocking and clock distribution and things. So
It had
that
fiber
console,
as well, though. The system.
it did, yes, it did have fiber as well. The fiber was called Hypermac. That's right.
Yeah.
So Supermac was the AS50 transport, wasn't it? But Hypermac was their proprietary protocol that ran between the DSP and the Surface. So you'd have a main and backup, right?
Yeah.
You'd run a pair of those. Yep. So you can run them on either Cat6 or optical, so on fiber. And from memory, I think they were multi-mode, so fiber. So yeah, there's so going on from there, we'd find that we'd have to get we'd have to get signals from front of house. We'd have to get high level mixers and stuff to monitors, and then we'd also have some stuff heading out to the broadcast guys if they had one as well, and we'd end up creating these rings. And we found that network doesn't like rings. It prefers very much a hub and spoke model. So effectively, we'd have to pick one console, and we got to the point where we added an additional console at patch to be that central console. That was basically our clock master, and we would that would be our hub, and we would have spokes. So we'd have front of house, we'd have monitors, we'd have broadcast, and this was still monitors. So front of house would have up to 2 consoles, monitors would have up to 2 consoles, and that went on for quite a few years. We still split analog, so we still had racks of I think the radials at the time, all supplied by Q Point Productions. So we were using the radial splitters, and we had like 112 channels of split that would go to 2 different lots of the 24 channel
431s.
Yeah, that's it. The DL431s. Yep. And the DL431s would even have splits on them as well, which we would use for various things. So, and this was because that console network was never really a gain sharing, you'd call it, sort of design. It was definitely designed around sort of each board gets its own preamp, and you could share the audio digitally. That was fine, but if you didn't have gain control, you're at the mercy of the other one. There was no gain compensation mechanism like you might be familiar with on other boards. So yeah, so carrying on from that, we did that for quite a few years. We hit every bump in the road that could be put in front of us. But we always got to the bottom of it. We always sorted it out, and we always had a working solution for conference. Quite often we would have other DL series boxes to interface with our video friends, and so we would go and put a node in the video control room, and we would do the handoff to the video contractor via analog originally. That had its own problems, so then we moved to the DN9650, if that's the MADI conversion unit. So then we started doing we would hand off via MADI, because their video router actually supported MADI, so they would do embed and de-embed on and off their router and hand that to us via MADI. That was a whole lot better because we didn't have such crazy fluctuations with level matching. We didn't introduce ground loops or anything like that, because essentially the systems were isolated via a piece of optical cable, so there is no ground.
And it provided a sample rate convert as well.
Yes, it did. Yeah, exactly. So that was doing the 48K to 96K conversion, because our console network was always at 96K. That was the native clock that the Midases ran at, and then we'd go from there. So moving on from that, we decided to change to a console platform that would scale.
We outgrew.
We outgrew.
We were so limited on channels.
The Pro 9s at monitors were maxed.
Yeah, the Pro. Yeah. And if you remember I reckon it was the last 1 or 2 events, I feel we went to the Pro 9s at front of house.
Yeah.
And we were just Yeah, we had a Pro 9 with a Pro 2 sidecar just because
it was getting crazy.
Yeah, the channel count became our limitation.
Yeah.
So that's why we were like, we need something a bit more scalable.
Yeah. So from the operator's perspective and a line list perspective, then absolutely. I was also getting frustrated at I would top out of, I would need an XL8 to do as the hub to do the routing between things and just as a router. And that just became insane. And we were looking at doing things like, running multiple 9650s with Dante cards in them and running a Dante network on the back end to do all the routing in between. And then it was just becoming crazy. And then at that point we went, well, all of us individually has had experience on Digicos. Juzzy and I have done some pretty large things together with Digicos, and we knew that those things running on octa-core can scale. Massive input counts or massive IO counts. You can put a crazy amount of nodes on an octa-core network and you can go from there. So we decided to make the change. I can't even remember what year that was, to make the switch and move to Digicos. So
I think that your background was the last year we used the Midas.
Actually, yeah, that's right. Yeah. I can't remember what year it was actually.
15?
Let me interrupt for a sec.
Yep.
Yeah.
And on this topic of scaling and changing different protocols and things like that, we've had a few questions about Maddie and Dante and, pros and cons of those and why you might choose one over the other. If at some point we could talk about that, that'd be awesome.
Yeah, we're definitely going to get into that in a little bit once we sort of where I'm kind of heading with this is now that we're talking about Digicos, we're going to get into octa-core, and then we're going to look at how we break out in and out of other systems from that loop. So we're going to look at I've put together a quick drawing of what roughly a conference network would look like, and then we'll go from there. So so we're definitely going to touch on both those protocols and pros and cons of both. So that'll be good. So our journey onto the Digico platform was really motivated around IO count, functionality, I would say. The Midas platform was an incredible sounding console. It sounded great, but it was the Pro Series and the XL8 was a digitized analog board. You know what I mean? All the functionality about it was analog and things like that. So in the earlier software versions, like, moving a channel strip was difficult. The automation was difficult. The just stuff you become so familiar with and is second nature, and just naturally you would just assume a digital console can do. These were quite limited in that. So there was that kind of operational functionality, and we're always getting curveballs thrown at us. And we always need to accommodate those, and we always need to, somebody will come and ask us something. So we want to do random busing and this and that and everything else, and spin up another matrix feed for whatever else. It's just, who knows what's going to be thrown at us. So we needed a console that was going to be really flexible, had the IO count, and that had superior networking. Especially. So that's when we moved to Digicos, the SD series, and we went to SD5, 7s, 10s. You name it, we've used it. So, but I mean, apart from that, like operationally wise, I mean, Crawford, you're primarily at front of house and Matto especially, so you're at monitors. I mean, Matto, apart from you, probably, I guess you'd say you've been kind of blessed because you don't know anything but kind of Digico. So
yeah,
great. It's a great world to grow up in.
Yeah.
But Croft, like moving from, going from, the previous generations of boards and moving from the Midas and stuff to the Digico, operationally wise, what did that open up for you?
Well, the irony is I've been using the D5 for years on all these other events. It was a little bit, if you actually, the Hillsong went down a path, somewhat driven by, Brad and Rudder, because they were doing a lot of the touring at the time, and they chose the Midas platform, and that dictated a little bit of what we ended up doing. And it was a great platform at the time, but the limitation So I was actually more comfortable going back to the D5, or then, you know, jumping onto an SD7. That was a more comfortable platform for me.
Yeah.
I've always found it much quicker to get round. The other thing that probably is worth understanding as well, and Juzzy and Ricki probably could talk a little bit more to this, when we did make this jump, Opticore really had also come of age. You used to be like a little bit of a wizard to make it work. All of us have spent, you know, 3 a.m. nights in the catwalk, you know, pulling out fibers and trying to. Opticore had a complexity about it, but they, you know, kept working on their platform. And by the time we decided to use it on conferences, and it was originally with some 7s, was what we went out with, some SD7s, and it just by that stage it just worked. You plugged it together. It was a very powerful, elegant solution.
Yeah. I mean, Jazzy, I don't know if you got something off the top of your head, but we've got some optical horror stories.
Yeah, but
You know.
both Ricki and I have worked on other events outside of Hillsong with Opticore, so we've got a bit of experience there. But yeah, back in the older days, if your fibers weren't perfectly clean and there was some dust on those fibers, you could have clicks and pops, and the diagnostic tools available at that time were very limited. So you just had to go through the system systematically, you know, connection by connection, make sure it's clean, and that could take hours and hours.
Yeah.
On a very large scale event, you have that time available to you, but for the conference where we're loading in and sound checking the next day, that sort of time isn't available to us.
Yeah, exactly. And it's come like so thankfully on a Digico Opticore network, you don't have to deal with SC connectors and LC connectors, and you're only dealing with the expanded beams, the HMA connectors, which are kind of really good. They're, you know, they are true tactical grade. They are military spec. You can pull them through mud and just kind of, you know, hit them with a hose or you know, shake them in some water and then plug them in and they'll work. And they're multi-mode based too, which is a bit more forgiving in that circumstance. But there's what we're talking about is the non-Digico Opticore side, which is basically Opticore as a company, as a manufacturer in Germany that makes network audio devices, primarily fiber-based, runs in a ring. Really highly available. IHA can withstand a break in the loop, and it's pretty fast failover. Incredible gear, really good, especially at the time that it came out. The engineering was unbelievable, but you had to have a very specific skill set and understand the quirks of the system to deploy a large system successfully. If you didn't have that experience, and then you would be running around, you know, for days looking for where these little clicks and pops and things like that were coming from. So yeah, no, that was a lot of fun. That was like, what are we at, 2020? So that was 13, 14 years ago. So now, so, you know, 12, 13, 14 years ago. So yeah, no. So like Crawford said, it has come a long way. It's definitely matured. It's the stability of it's amazing. So yeah, so we decided to make the switch and we jumped across to the SD platform, and we haven't really looked back since. So, and it was pretty crazy the early days, especially when we were running the Midas, because we were doing things like 5-way analog splits.
And that was find a photo earlier, but I couldn't find it.
Yeah, I should actually go through. I know there's someone posted on my Instagram actually. There's like the crazy amounts of splits and stuff we had to do, and you know, and then you'd be wondering where all your game went, and you know, and then there would be like a hum introduced on a system, and the guys on stage would be scrambling to try and find it, and they wouldn't find it. But turns out it was a direct loop out of, you know, preamp stage track A to stage track B or something like that. And yeah, anyway, it was a lot of fun. It kept me awake. It kept me busy. So, but like those days were a lot of fun, but I'm glad we don't have to go there again. So, and we would be we would have 5 lots of stage racks just for conference itself, and that didn't include the guest system for the guest bands, which was another set of splits, another set of stage racks, possibly another record or broadcast console.
Oh my gosh.
Yeah, it was full on. So the old
Patch
Patchland
World just used to, it was mammoth.
it was
The
huge.
amount of
Yes.
analog cable was just out of control.
And like multi-pin for days. And there would have been, I want to say in the order of probably 400, 500 points of like interconnect, you know, various patching, so, and things like that. So it was pretty crazy. Thankfully, things were in large blocks and a lot of it was multi-pinned and things like that. So you could test it in the shop and wheel it out and it'll work in for the event. But you know, it didn't come without its problems as any large scale analog system does. So yeah, it's you know, again, like I said before, it was a lot of fun, but I really don't want to go there again.
No.
So this is where I'm going to quickly share my screen and just show everybody. Sorry, the technology is hard.
One thing I will say, when we also made this choice to go, you know, to a full, well, you share, Ricki, figure that out. But everyone was ready to do it, you know, and Ricki will talk about this, like comms, TV, everyone was ready to embrace a fully digital transport. So it was, the timing was right.
Yeah, that's right. There was an alternative motive when we moved to a network-based transport mechanism, and that was to try and take a lot of the other departments along for the ride, and things like because at the end of the day, comms is just audio. You know, it's really no different. So having a digital network and then handing off to them via analog, and then or handing off to the video guys via analog, or you know, there was really no point, because as we kept adding things, you know, there'll be always, you know, there's an initial +1, +1, +1. Oh, can I get a 4-wire for this? And can I get a 4-wire for that? And all that would mean is you'd have to go over, get another, you know, whatever it is, D-sub breakout or another set of XLRs and plug something else in.
XLR to what is it? Cut that stupid adapter.
So, you know, RJ45 breakout cables, XLRs and things like that. And if you know comms, and when I say 4-wire, and I mean, you know, a balanced input, balanced output, everything comes in a pair. So it's for every input, you get an output. So you might have, it might be in favor of majority of the outputs and you have very few inputs, but you don't get that choice. You got those inputs anyway. So there's lots of these breakout cables and like just spaghetti that would be patched together in the back of a rack, and someone will lose a feed to or from comms and you're sort of, you know, scrounging through the rack trying to find it, rather than just kind of going to a GUI and going, oh, hang on, click, there you go. Yeah. There's a cross point. So yeah, so moving to a network-based system, we originally started, and you can see my screen here. So really simple loop of opticore, that's here in black. There is nothing special about that. I've thrown the SD12 in there as a, look, this has changed from year to year to year. The SD12 would be my preference because we also need a utility console at Patch to do things like take all of our local talk mics at the consoles, put them into a mix, and then feed that mix into comms, and then bring a feed back from comms and, you know, send it to all of the consoles and things like that. We do mix minuses of those talk mics back to each other so everyone can hear you, but you don't hear yourself. And that saves channel strips on everyone's console to have front of house talk 2, monitors talk 2, you know. Instead of doing that, you could do that, and there's nothing wrong with that. And you can do that very easily on an optical loop, but we were trying to conserve channel count, and we're trying to bring it all down to one fader, and that just made it easy. We just do a mix minus on the utility console here at Patch, and voila, away we go. Other things like it allowed me at Patch to be able to monitor sources, especially sources that are coming off another network. either, via MADI and being injected into the optical network. So that's what that is. Last Hillsong conference, this was simply replaced with an orange box. Last color. So color 2020, which actually did go ahead. This was replaced with an orange box. So yeah, simple as that. So we've taken even this through a few evolutions, and once I get to the other side of the page, I'll talk about that a bit more. But effectively, this is a, supplementing an AES feed, and that's a Lake LM44. That's just purely there. We use a lot more than just one, but that's just representing the feed to the PA. And I'll get Josie to talk more about that in a second. But yeah, moving to optical, it's such a simple network. It's just a loop, and you just add more devices as you need them. Josie, what's the actual max channel count? Is that 1024 still, or?
It's 1024 when you're in non-Digico mode, but when you're in Digico environment, I think it's 504 or 506.
Yeah.
The hardware is capable of the bigger channel count, but what Digico do is they basically say our consoles will do the exact same thing at 48 or 96.
Yeah.
So yeah,
they don't halve it on you. Yep.
Exactly.
Yep.
Yeah.
Cool. So
let me pop in with a question. Sorry.
Yeah, go for it.
We just have a question about, is the Yamaha CL5 or PM5 able to be equal functionally to the SD series and in all its accessibility and everything?
The new PM5 that was announced yesterday, I think, is basically, it's a direct replacement for the PM5D, actually, the old PM5D. Yes and no. That's a very, as far as channel count goes, yep, because you can get a 120 DSP or a 288 DSP. So on the 288 DSP, yeah, absolutely, you'll be able to keep up with any of these big guys. But with the 120 DSP, you're kind of talking SD10 kind of channel count.
Yeah,
that's it. 288, you'll get it up to not quantum, not SD7 quantum or SD5 quantum, but you will get it up to, not quantum 7 rather. They're not SDs anymore, but you will get it up to an SD7 series. You won't get it up to quantum because quantum takes it to a whole nother level again.
But transport-wise,
transport-wise,
can you achieve the same thing? I think is probably the
Well, yeah. So Yamaha have their new protocol called TwinLAN E. Well, it's not new, but they've had it out since the PM10, since they launched the Rivage series. TwinLAN. So basically, that's redundant 10 gig links. You can create a loop that's much the same as this, and you can put, I don't know what the actual total channel count is, but you can put a lot of channels on it. And on their frames, you can break in and out on Dante cards, MADI cards, whatever you want to do. So yeah, it's definitely, so obviously with a PM5 network, you'll be able to use TwinLAN to the DSP. The DSP can have a MADI card in it. Sorry, not a MADI card, a Dante card. And then from that Dante card, you can hit your QL series from there. Okay, but your QL won't talk TwinLAN like your PM will.
No.
Yeah. So, yeah. So basically you see the SD12 here. That was a utility console. That would be used. So over the years, we've never actually used an SD12. I've always asked for one, but we've always gotten a SD10 or something else. They're just, for some reason in Australia, there is a lack of SD12s or SD12s with optical.
SD12s with fiber.
With fiber, yeah. Everyone buys SD12s, but they forget to order the optical module for it. So I've just put an SD12 in there because that's ultimately what I'd prefer. And that has essentially on the, we would use the DMI slots or the MADI ports on the back of an SD10 to interface because this whole ring runs at 96K. Okay, so we run the boards natively at 96. And then we need to interface with a traditional 48K network. So this little guy here is our sample rate converter. And that basically takes 128 channels in at, now guys, this isn't completely accurate because I haven't drawn as many lines as what I should have, but that's 128 channels in. So 2 lots of 48K MADI streams at 64 channels each, and then converts it to 4 lots of 32 channel MADI streams at 96K. And that'll basically be a bulk lot of 128 channels on and off our backbone network. And our backbone network for the last however many years, it's been quite a few years now, has been based on Riedel's MediaNet. And I'll get to MediaNet in a second, and we'll talk about why we use MediaNet. But yeah, so the other thing is you can see another MediaNet unit here, and that's got a pair of MADIs coming in and out, but you notice there's no sample rate converter in line. And that's because the SD racks have onboard MADI ports that can actually output at half the system clock. So they've got onboard sample rate converters that will actually spit any input coming in here is, and Josie can talk more about this, is basically sampled at like 192K, put onto the network at 96K, and then we can talk about, then it's outputted as 48K. But Josie, correct me if I'm wrong with the way SD racks work.
No, that's totally it.
Cool. Yeah. All right. So yeah, they sample at a really high sample rate on a per channel basis. And you know, what would you say would be the primary reason? Is it resolution? Is it the ability to be able to hand off in multiple sample rates? Is it all of the above?
It'd be all of the above, and especially with the 32-bit pre cards now, it's about noise floor as well.
Yep.
Yeah. You know, I've had a couple of people ask me, you know, like, why is there a 32-bit pre in a 24-bit digital loop?
Yep.
And essentially, they sample the audio at the full 32, and then take the lowest common denominator, like the lowest value 8 bits, and discard them. So your noise floor.
So they basically bury the noise. They delete the noise floor.
Basically.
Yeah. Which is actually pretty smart.
Mm.
So, yeah. So we output at 48K, and we hit another MediaNet node. This is a compact, is what they call this one. This one up here is a micron. So we'll get on that in a sec, because as you see other lines running off. But before we go that too far, Josie, let's talk about the PA network, how we drive the PA. So basically it's going to be AES out of the back of the front of house console, or an SD rack if it's down at stage. Either way, we hand it off as AES, AES3, and then it hits Josie's world.
Yeah. So
I'll let you take the screen.
Yeah. So in previous years, it's been a bit different to this, but this is what we did. I'll show what we did last year, and then we can talk about previous years a bit more. You guys can see my screen now?
Yep.
So basically where Ricki's AES came out of the console and hit the lake is this little guy here at front of house. Now, depending on the complexity of the PA, that might be 1, or I can't remember how many he had last year. Was it 9 or 11 LM44s at front of house?
Yep.
To distribute, to distribute audio. But in a nutshell, it comes from the consoles at 96K, hits the LM44, and then we head off to the rest of the system at 96K with Dante, a primary and secondary loop. Typically, it would go from front of house down to somewhere near monitors, and at that point, it would branch out into the various different things. So you can see here monitors here. So normally it's a pair of fibers from network switches at front of house, down to a pair of switches at monitors, and then there'd be a pair of fibers that go into the roof and then go to all the different racks in the roof. And there'd be another pair of fibers that come, here, the floor, fill and sub. So we do another pair of fibers, all copper, from monitors to under the stage to feed all the subs and front fill amplifiers as well. Yeah.
And what sample rate do we run that at?
It's all at 96K.
Cool.
Yeah.
All right, so we keep it native 96K for as far and as wide as we can.
And so clocking wise, just talk through how that system is clocked to the other system. Because we've now gone from MADI to Dante.
Yeah.
Well, AES3 off the back of the board.
AES,
AES output to hit that LM.
Yeah, so the LMs, the Lake platform's really flexible in terms of sample rate conversion and who can be a clock master and what you want to do there. So it's really up to you. But last year we clocked to the whole network from the AES feed from the console. there was a small issue we had last year, which I don't think we'll do that again. Essentially, basically, the clock was coming in. We had a small glitch in the clock, and the Dante network saw that glitch, and it had to resync all the devices to the clock again, which caused a brief mute in the audio. So now we're going to do sample rate conversion every time here, so that the whole Dante network can run on its own independent clock, and no matter what happens prior to that LM44, the network will stay stable.
Yeah, won't actually matter.
Yeah.
Yeah, so that was basically caused by a small glitch in a silly problem that happened out of our control.
Yeah.
But yeah, upstream clock had a slight hiccup. It wasn't a complete failure, just had a slight hiccup. And because we had synced everything to everything, that was a big flow-on effect. That was a big domino effect across the whole network.
Yeah.
You know, and it was a very brief glitch, but it was enough to cause the PA to mute for a split, for a second or two. So by putting that sample rate conversion in, like engaging that in at the front of house node, we're now creating a demarcation point. So we do AS3 handoff to the LM44s or to the lakes, and then Dante on the back of that, and that is a self-clocking. So the front of house node will probably still be the master, but that's a self-clocking network, and keeping it independent. So whatever happens upstream of that won't actually affect anything downstream.
Yeah.
So, and that's just a lesson we've learned. And,
Exactly.
and this is basically, you know, why we're here to talk about these things. We're going to talk about everything we've experienced and we've gone through and gone, well, we won't do that again.
Yeah.
So, you know, and then share it with you guys. So, and again, this is why we would be leading up to conference, you know, if we were to have it in 2020, we would be planning these things and going, okay, so last year we did this, it caused this, okay, how are we going to engineer around that? What are we going to change this year to make sure that that doesn't happen again?
Yeah. We did that exact change in color this year.
Yep.
Yeah. We realized that was, although we wanted everything to be on the same clock and in sync, it actually caused an issue later down the track. So yeah, during color, we did a sample rate converter at front of house at lakes before it hit PO.
Yep.
While we're talking about various forms of audio transport, can we discuss quickly how that works for recording? If we do an album record during conference, what's the process for getting, you know, audio inputs to whatever broadcast situation?
Yep, definitely. So there's actually two. Okay, so what I'll do is I'll talk about broadcast very quickly, because we kind of do broadcast a little uniquely. Is that even a word? A little bit special, I would say, compared to others. But for both of our major conferences throughout the year, Color, which is at ICC, the International Convention Center, Sydney International Convention Center, and Conference, which is Kudos Bank Arena, and that arena changes its name. To me, it's still the Sydney Superdome.
Stupid.
The Superdome. Yeah, so what I'll do is I'll quickly, I'll share my screen again, and we'll go back and we'll look at the other half of that drawing, because that's where it gets a little fancy. So, all right, you guys should have that. Okay, so as I mentioned before, the SD racks are now outputting MADI at 48K, and we're bringing both MADI feeds at 56 channels, 57 channels, if you understand the Digico version of MADI. So Digico, it's a 64 channel frame rate with 56 channels of audio, and the 57th channel is the control data. So that's how you control your stage rack. So if you transport that control data over another network, and you maintain the bits and you don't modify the bits, and it's frame accurate, then you will actually be able to remotely control your Digico stage racks. So that's for the longest time that was not a supported, that Digico didn't support that. As you know, you couldn't open the manual and go, how do I remotely control my stage racks? You know, they provided software you could interface via USB and things like that, but it was kind of a bit of a hack. If you knew, if you understood it and you knew how it worked, you could make it work. And that's exactly what we did. But now they actually support it, that you can do remote stage racks using the orange boxes. So you can have a pair of orange boxes at each end, MADI from your console, MADI from your stage racks into an orange box, and have Dante between. And you can do remote control of the stage racks via a network or an IP network that way. So as I move over here, you can see, we're leaving on MediaNet, and sort of let's look at the Hills campus. And that's actually where our broadcast facilities live. So we have two facilities. We have, and I've kind of roughly drawn them up here. We have a larger facility with a Digico SD5B, and our smaller facility's got a Digico SD8. So this is what we call this is basically the 128 channel facility on an SD8. And this is the 256 channel facility. So, just one that's twice the size. What we do is because Riedel is our partner for conference, they're our media transport partner. They provide a node that we pop into our Hills campus, and that's literally on 40 kilometers of fiber that we as Hillsong Church, we lease that fiber. We lease it all year round, and we have dedicated fiber into ICC, and we have dedicated fiber into Kudos. And that's not just for audio, that does video, it does Ethernet, like IP data for the IT guys. All of the, if we add additional Wi-Fi or we need to control devices back at home or anything, we can put it on that fiber. And typically we split it up using CWDM, coarse wave division multiplex. So that's effectively each channel of fiber is on a different wavelength, and they just sum through a prism, and we send it down that raw piece of fiber. And that's a single mode link. So that's roughly 40 kilometers away. And we mix broadcasts using our own facilities back at sort of head office at the Hills campus. So we started doing that as a primary, we really did that because we started to find having broadcast on site meant we were struggling to find rooms as the conferences grew. We were running out of space. So we started using outside broadcast trucks, audio only trucks. And obviously they came with a great expense. So we kind of looked at it, and I kind of looked at it and went, well, we've got the infrastructure. We own the fiber. We have the facilities. Our team is comfortable in our facilities because it's the way they like it. So why would we bring them in? And at the time, there was very few trucks with Digicos in them. A lot of them were like Studas and Lavos and things like that, which kind of had each of them had their own quirks, and each of them required their own learning curve to wrap your head around them. And, so not only are you paying for the truck, you're also paying for tech and everything that comes along to them. So that's where the expense came up. So we looked at that, and we spoke to, well, initially we actually did it via IP. So we connected the broadcast rooms at Hills campus via, like, imagine if these units here was replaced with a Lavo product called a vRemote, and that would enable us to transport, each device was able to transport 128 channels of effectively MADI to AES67 conversion, or Ravenna in Lavo's world. So we would effectively take the two SD racks, we'd take the MADI feeds in, we would convert them to AES67 or Ravenna, and transport them to home, to the Hills campus. And then they would pop out and either be restreamed to as AES67 to our core audio routers, or would just be a MADI link, depending on how we wanted to do it for that week. And this is a very, very basic version. It's a lot more complex, but the convention center based broadcast facility's got a Lavo router in its core as a facility router, the Diotech M1K2. So it's MADI down to that guy, MADI off to the console. So these consoles run as MADI only. They do have optical cards, but they're not actually plugged in on the optical loop. And I should point out, because we're using the onboard sample rate conversion in the SD rack, it stays 48K the whole way.
And how long?
Yep.
You know, because I know we've tested it.
Mm-hmm.
How long does it actually take the audio? You know, so
the round trip was like
4Ks, various conversions.
Yeah, the round trip was like 1.6 milliseconds or
Yeah.
something. You know, so it's nothing.
And the audio goes back to the site. And
Yep.
That's what broadcast people listen to in the TV control room.
That's right. So yeah, in the TV video control room, that actually goes down, and that's what I've sort of drawn down here. So this is kind of just a representation of the video control room. Again, it will have its own MediaNet node, and what they actually do is they don't use the rental company's router. They actually use MediaNet as the router, because what we've found over the years is that you basically build a rack of microns to do all of your I/O, and effectively, because you're pushing everything into MediaNet and pulling it back out of MediaNet, MediaNet can do your routing as well. So you're basically building a large distributed router. So we do that because, you know, this is just a picture of PVP, but essentially they'll have video playout servers that will be, you know, SDI into a micron. And then what we do is we de-embed the audio straight off the back of that SDI signal. And then that's available to us, you know, via another one where it gets converted to MADI at 48K, sent through the sample rate converter into the patch console. And then we then do a copy audio onto the optical network. And now that video server or that video playout machine is now available as an input, you know, to the house consoles. And it's really as simple as that. So if the video boys come along and they add another playout server, or they go and add another recorder for any reason, they plug it in, the signals are available. It's as simple as that. Previously, if they had done this, it'd be another pair of XLRs, and we might be out of analog IO, and, you know, there could be numerous reasons why that.
Or we used to give the video boys a mixer, and they would forget which channels to turn up, and we would be playing videos with no audio. Yeah. All of the horror stories.
Yeah.
So this way it removes any operator help.
That's right. Yep. Any assistance.
Any assistance.
So, yeah. So basically 40Ks away. So we're remotely mixing broadcast there. We send 192 channels total. So we effectively send the same two SD racks that are on the loop at 48K. And then all of these additional signals that come in on and off the network via MediaNet also go over because effectively once they hit here, they'll be sent as another block of 64 MADI into our facility router. And hit the console, and effectively hit the console that way, and that's just Pro Tools. So Pro Tools being the multi-track recorder with a couple of sound devices, SD970s running as the backup. So yeah, so as Crawford mentioned before, the audio is mixed here, and then it's actually sent back. It's actually sent back to the venue that we're renting at the time. Fed back in for the record guys. Sorry, not the record guys, for the video guys to record on their decks as reference audio. It's creating stems that get broken out for various mixes. It does numerous things. And then ultimately as the backup, in case that link ever gets severed, front of house is generating the same stems. And there is a macro that will switch the feeds from there, you know, back here. So again, front of house is generating those mixes, hits the patch console. I monitor those at the patch console. I also monitor the feeds coming from broadcast at the patch console. And then that'll be fed MADI at 96K, back into a sample rate converter, back into MediaNet at 48K, and then it's on the network. And once it's on the network, we can do anything we want with it. We can send it anywhere when it needs to go, and vice versa. So the point of using MediaNet as your video router means that all of those SDI sources and those SDI destinations all have every channel is available to be de-embedded or embedded to. You don't have to worry about, we used to have things like, we went through a stage where we would rent trucks from NEP. And these trucks were, like, you know, these were 48-foot double expansion, real broadcast trucks. And we would run them out of converters, and we would run them out of de-embedders and embedders. And we would run them out of all of these things that you end up using in a live production that you may not use as many in a standard, you know, television production like sport or something. So yeah, it was always kind of crazy like that. So switching to a platform, especially a modular platform like MediaNet, took all of that headache away. You didn't have to consider if you had a spare embedder or a D embedder. It didn't matter because that SDI port could be either. And you can get audio in and out, and it's just effortless. Same deal, and I haven't drawn it here, but same deal with interfacing with the comm system, which is again Riedel Artist Series. But it would just simply be MADI off a MediaNet node in and out of an artist frame. You know, if you needed an extra 4-wire, no dramas, just patch it through and it's good to go. There was no searching for XLR to RJ45 breakout cables and finding a pair of XLR cables, and no Crone punch down, or as the, as our American friends like 110 punch downs and things like that, IDCs, all of that sort of fun stuff. None of that. Keeps it clean, keeps it bit accurate. Yeah. Now, Crawford has mentioned a few times the clock. So clocking is super important and so often forgotten, or left to be discovered the hard way, about how important it is. So I've drawn this in this dotted line here. So effectively, we end up using MediaNet. And for color, MediaNet, the MediaNet network itself would be the master clock. Typically, this will be the Metro N or the Metron. One of those guys would just be the master clock. In conference, when we have to interface with an OB truck and things like that, we'll typically take clock from a GPS synced SPG, so a sync pulse generator that's synchronized to GPS. We do that for a couple of reasons. That also supplies time of day time code, which is also available on the network to feed, for example, Pro Tools, any recorders that we might have, like you might have a little Reaper system running at front of house. We can bring time of day into that, so it's being recorded, and the timestamps are accurate. But effectively, MediaNet is capable of outputting multiple clocks. So we take a 96K clock, even though MediaNet's running at 48K, it can generate a 96K clock, and we feed it into the very first SD rack. And as soon as you introduce a external clock into an SD rack, it'll instantly prioritize itself to become the optical loops clock master. Okay, so all of the consoles, you just select opticore as the master, and as soon as you introduce an external clock into an SD rack, it will elevate itself to become the master and the external clock interface of the optical loop. So that simply takes care of that. That avoids having to do asynchronous sample rate conversion and things like that in these frames, which you can do, but we avoid doing sample rate conversion, asynchronous sample rate conversion to break up clock domains if we don't have to. Obviously, the lake at front of house is somewhere where we decided that we want to and we would have to.
Yeah, that's a function of how Dante deals with the clock change as well.
Exactly. Yep. Yeah. Exactly. So that's to overcome that, that little issue there. If that to ever arise again, that would take care of that. Cool. So I think that pretty much nails it. So, I mean, we've got, we didn't talk too much about Dante and Matty, but I mean, there is every protocol under the sun here. We have Opticore, we have Matty, we have Riedel MediaNet, which is a TDM-based system, and TMD is a time domain multiplexing, which is effectively, in a link, you have a certain amount of time and you have little chunks carved up, and those chunks are allocated. So, this time slot is for the AES signals, this time slot's for the SDI signals, this time slot is for the Matty signals, and everything gets its own space. So everything is always sample accurate and timing wise very accurate, and everything's delivered in time, and for us, especially in phase, especially when you're dealing with multiple Matty streams going in and multiple Matty streams coming out. You want all that to be completely synchronous across the board, because you might have a stereo channel that's channel Matty 1, channel 64, and Matty 2, channel 1. You want to make sure that those two streams are still in phase or absolutely synchronous, so you don't get any weird warping in that stereo image. That's just one of many examples. And then we discussed, obviously, utilizing Dante for the PA. So Dante is a really simple, really robust IP-based protocol, that runs on top of Ethernet. And that works great for distributing around an arena to the PA. You can do that over Cat5, fiber, Cat6. It doesn't, choose your choice of layer 1, but either way, layer 2 and 3 are still the same. And that just works really well. All right. Anything you guys want to add?
I guess the sole one, obviously one reason to go down that road is interconnectivity to the Hills campus from the venue, the consoles we use, but having all that I/O available at the click of a button and the flexibility that gives us, this gives us as a team and the flexibility to react to changes and requests that come our way. Hey, we want to do a thing over here. At the last minute, we can more easily facilitate that request.
Yeah, absolutely. Because not only that's a very simple version of what MediaNet would look like on site, but typically on one of our conferences, we'll have a TV studio in the foyer. We'll have the guys running backstage, online and all sorts of stuff like that. So we've got signals coming and going everywhere. And like Josie said, having it at a click of a button, just makes it so much easier. You just, you don't even have to think about it. It's, oh, you want from that to that, no problem, done.
I was gonna one of the years, and it was only a couple of years ago. I can't remember. It was Carrie Job or one of the guests. That they didn't bring engineers, but we gave them their own rack and had it on the network, and within, because we were on a 7 and up front of house, we just had those channels existed on the network the whole time, from bump in to bump out. And whenever they got up to play, they had their own dedicated channels, and we didn't need a second console. We mixed it on the same surface that we mixed the rest of conference. So it's had certain things like that. It's had great advantages, which you just can't do if you're not on the network. One of my favorites is if it's dirty and it's on the network, it's dirty for everyone. And if it's on the network and you don't have it, then you've patched it wrong, because
that's right. Yeah. That's it. If monitors have got it and front house doesn't, you don't call patch.
Yeah.
It's like, if one console has it, then it's available for everybody.
For everyone. Yeah.
So typically, and I mean, we've done some crazy stuff over the years. I think Jazzy can, if you remember, we went down and we used SoundGrid as a platform.
We used SoundGrid to, that was our utility router and mixer, wasn't it?
We used LV1 as a mixer.
Yeah, so I think we had, was it 1 or maybe it was 2 MGBs at front of house, 2 at monitors, 2 in the Studer truck that we had that time, and was there 1 in video as well? Maybe.
Yeah, we broke out to Maddie, so we literally just went and dropped a little MGB with a power supply. Dropped it down to the senior, sort of the main broadcast engineer or the video engineer, and ran a Cat5 and plugged it in. Went, here's your Maddie, and he kind of looked at us and went, okay.
Hey, it worked.
It did work. It worked great, actually.
Yeah.
That's yeah. I mean, I was trying to think of why did we actually go down that path? We had a bright idea
available to us.
I reckon it was what was available to us.
Yep.
I had a pair of MGBs, I think.
Yeah.
So
Brad had a pair, and we got another one, and I
mean, it was a fun experiment. We wanted to try it. We wanted to use LV1. I mean, I stuck pitch shifters on people's talk mics. It was great.
It was, but probably that's in the bigger picture of this. We used resource that was there because a lot of people probably think we have an endless budget at conference. And there are things, I bring my own mics, we've all brought our own personal equipment over the years to help make conference great, because sometimes we are scrounging, it's not just this open-ended. And I reckon that's why we went down this path. It was like, we've all got these bits. We want this network. We could create it without,
I mean, for a couple of years when I was studying networking and I had a lab of used Cisco equipment, I would literally deconstruct the lab and install those switches in the back of the RF racks. and they would show up on site, and that would be the, you know, the RF management network and things like that. So, you know, yeah, we definitely, everyone contributed. And we kind of like, again, it was the fun of it. But I actually remember that was like predating MediaNet, the decision to go down MediaNet, because everyone's still a bit hesitant about, you know, jumping on one platform. Everyone kind of wanted to do their own thing, and that was fine. But we were kind of like easing everybody by bringing these, you know, this little box that we threw down, and at 48K that had 128 available IO. You know, and that was pretty cool, right? So if yeah, I don't think I actually think a lot of people don't leverage the power of SoundGrid enough. The networking capabilities, that is, it's really simple to use. It's relatively inexpensive in comparison to, like, you know, buying MediaNet nodes or buying Tech or, like, you know, direct out or Lavo routers and things like that. So yeah, as far as an Ethernet capable or a mode of transport over Ethernet, it's actually really good value for money, in my opinion. Yeah, cool. All right.
Pooch says it sounds great too.
Pooch says it sounds great. Yeah.
Yes.
That was cool. No, but yeah, no, we had some fun because we were running LV1 as that utility mixer, doing all the mix minuses on it. It was like, well, I could add a plugin, so I did. It's like, why not?
Yep.
Things like that. So, all right, Matt, we got any questions that we haven't answered?
Just if this is going to be available to watch after.
In some form or another, we will get it out there for the public to view. Okay.
Yeah, we'll make a post with a link to where you can watch it, and that'll be that.
I was going to say, let's just answer this, you know, it's not related, but this LUFS for broadcast, because it's pretty relevant.
Yep.
But, so broadcast audio traditionally is a neg 10, but in this current world of streaming, if you're unaware, and the main one that we've all been sort of trying to standardize to is YouTube live streaming. And they've gone with this neg 14 standard. So if you don't transmit neg 14, and there's heaps of info on the web, you can Google this. There's even programs where you can input your audio and it will show you what the algorithm's going to do. If you don't sort of have a neg 14 average broadcast transmission into YouTube live, it will normalize it for you and turn it up. That may not be what you want. So if you get your level up there, which is pretty loud, I'm going to say it's not, you know, but that's what they've decided. So if you're using YouTube or Facebook, that's the kind of place you need to be. So probably if I've explained this or if I haven't, broadcast, traditional TV broadcast is very different to this world of live streaming that we're all going down. There is heaps of info, Google it, but yes, so it's not a neg 10 standard for any of these YouTube live things, etc. So yeah.
So I just posted a quick link. I won't share my screen, but because we do need to wrap it up. But I just posted a quick link to you can download it as a free plugin, VST plugin, but you can also buy the pro version, which is like $80 or something like that. It's not much money. And it's got templates. So you can pull up the YouTube template or the Spotify template or the whatever Facebook template, and it will actually then tell you how you're tracking, if you're over, under, things like that, how to maintain. So your LUFS or LUFS, things like that. A lot of, and I kind of need to clarify very quickly on, a lot of people see our posts and they've heard me talk about it before, with us going out at literally 0.2. Well, minus 0.2 rather. I shouldn't say 0.2 because that'd be clipping. But yeah, neg 0.2. What the reason we do that is we do that for maximum resolution in that window. And then from that point, when we do a handoff to YouTube or a handoff to Facebook, we level match it to what they want to see. But what we do is we make sure that the signal we're giving them can't be modified by them because it meets their specification exactly, right? So when we hit that, we don't want a crazy dynamic range because we don't want the average. And it's funny because when Pooch and Chris Raybold actually were talking about this on their previous YouTube clip, about where the average RMS sits versus your peaks and things like that. When we're doing that, we're driving that final stage after various of others sort of DSP. We're driving it into an L2, and that L2 is maintaining that the whole way on the output. So we have a constant, steady output. And then we're actually sending that and handing it off to our streaming team, and our streaming team are then usually under the guidance of me, are more or less sort of adjusting that and sending it to each cloud provider, Facebook, YouTube, whoever, streaming platform. And we do that so we don't give them an opportunity to do that. Like, we make sure that the signal we hand to them is as good as it possibly can be, so they don't need to modify it. And we've found that works a whole lot better. So I've got a bunch of DMs about, hey, how does Hillsong get their audio to sound like, so big, wide, and dynamic on YouTube, but ours sounds crunched and squashed or has a high noise floor or whatever. And it's basically down to, like Crawford said, it's the leveling that you send them. They all have standards. Go and click that link. Have a look at that little plugin. It's a cool little meter. Buy it so you can get the additional templates, the referencing features, and that'll give you a guide on how you're doing. And if you don't have a DAW or a DAW or anything to run that on, just go and download Reaper. Yeah. Use an interface, a 2-channel interface. It doesn't matter. Just gain match it so your 2-channel interface of your left and right coming in. Load that plugin in Reaper, and then just use that as an analyst tool. Yep. All right, simple, free, well, effectively free, very cheap way of doing it.
Yeah.
Exactly.
Cool. All right. Well,
Sweet.
I think that wraps it up. Guys, if you've got any questions, feel free to go and hit up. Best place to do that is on Instagram. Go and hit up the HS Creative Technology Instagram account. Post your questions on the audio webinar series posts, and we'll make sure that we bring them up as topics, and we try and attack them from there. But as always, thanks a lot, friends, and we will catch you next week. Before we sign off, we're just going to quickly make sure you go and hit up YouTube. There's a lot of content from the guys like Pooch, but especially go and have a look at our Crawford's content, because in some of his very early Mix Wizard episodes, he does cover, and quite in depth, mixing for streams and mixing for broadcast. Cool stuff on parallel compression. Sorry. Basically all the fundamentals that you really need to know to go down that path. And we'll definitely talk more about that in the future. We might actually dedicate an hour or so to it, because that's definitely a topic upon itself. So, all right. Thank you very much. And we'll see you next week.
Sweet. See ya.